Okay, so 9.8 is all about using those sum and difference formulas that are at the bottom of page 9 on the note packets. Those are the ones that I chanted for you. So we're looking at sine, cosine, cosine, sine, cosine, cosine, sine, sine, tan, tan, 1 tan. So hardest to remember, I think. The more we use them, the easier it'll be to remember them. A couple of things I'm going to point out here, and then I'm going to do a lot of these with you, but a lot of these I'm going to ask you guys to do on your own and then check the work as well. So if you're looking at the notes handout, I would highly recommend you take a look at this line here. The sine of A plus B is not equal to the sine of A plus the sine of B. We are not allowed to go in and separate out the A and B and then expand it like that. So remember, there's special formulas that we have to use in order to be able to expand sine and cosine, because sine and cosine are functions that are doing something really special to those angles on the inside. We can't just break it out as two different things. So in example 1 here, we want to use the sum or difference formulas to find the exact values of these problems. You are not going to be using a calculator on these, so we want to make sure that we've got everything simplified as far as possible. Your homework's going to ask you to do the same thing. So you're not going to represent anything with decimal values. Make sure they're all simplified radicals. You can always check your answers with a calculator, but a calculator is not going to help you get the simplified radical answer here. This is something typically I would test, obviously, without a calculator. So you're going to want to make sure to try that so you're ready to go for pre-calc next year. Okay, 15 degrees, not a unit circle angle. So the goal here is to be able to use those trig identities to allow us to solve for values of angles that are not on the unit circle, not nice angles like 30, 60, 45. So 15 degrees, there's a couple ways we can do this. The book is going to do it one way, I'll do it a different way. The sine of 15 degrees, I can express that 15. That's the same thing as saying 45 minus 30. So we can express 15 degrees as 45 minus 30, and then we have the following problem. This becomes the sine of A minus B, where A is 45 and B is 30. So we expand the sine of A minus B like this: sine, cosine, cosine, sine. The sign stays the same. Sine and same both start with an S. All right, so I'm going to fill in what I know about those angles, right? A is 45, B is 30. So it becomes this problem: the sine of 45 times the cosine of 30 minus the cosine of 45 times the sine of 30. These are unit circle angles now. That we can evaluate without a calculator. So the sine of 45 is root 2 over 2. The cosine of 30 is root 3 over 2. And then the cosine of 45 is root 2 over 2. And the sine of 30 is 1/2. So it looks like we've got root 6 over 4 minus root 2 over 4. And I can combine those with a common denominator. The final answer is going to be root 6 minus root 2 all over 4. That's how we're going to simplify that. That is what the answers are going to be looking for on the homework. All right, take a look at B. Now, the tangent of 7 pi over 12. 7 pi over 12, definitely not a unit circle angle. There's a couple of ways that we can go about doing this. I think that working in radians can be really difficult if we're looking at different angles to add together, especially when we're looking at fractions, because they might have different denominators that get us to 12 as the denominator of 7 pi over 12. So what I would suggest doing is turning 7 pi over 12 into degrees and then going from there. We can do that by multiplying by 180 over pi. What happens is we get 7 times 15, which is 105 degrees. So that's one way. You guys can also do it in radians. The radians would be pi over 3 plus pi over 4. But 105 degrees, I think, is easier for us to kind of break down. So 105 degrees is 60 plus 45. I'm using unit circle angles so that we can do this without a calculator. 60 and 45, that's pi over 3 and pi over 4. But I think, again, turning it into degrees is a little bit easier to kind of see. So we're expanding the tangent of A plus B here. So that looks like this. That becomes tan A plus tan B over 1 minus tan A times the tangent of B. tan, tan, 1 tan, tan. That's how I remember that. All right, so when A is 60 and B is 45, we are calculating the tangent of 60 plus the tangent of 45 over 1 minus the tangent of 60 times the tangent of 45. Okay, so the tangent of 60, that gets a little bit complicated. I'm going to do kind of the work over here. You guys can do it on the problem. That's fine. The tangent of 60, a tangent is always y over x. So the y coordinate of 60 degrees on the unit circle is root 3 over 2, and the x coordinate is 1/2. So if you're looking at the ordered pair on your unit circle for 60 degrees, we've got root 3 over 2 over 1/2. So that simplifies to just root 3. So the tangent of 60 is just the square root of 3. So we got the square root of 3 plus 1, the tangent of 45 degrees is 1 minus the square root of 3 times 1. So it looks like our final answer is 1 plus the square root of 3 over 1 minus the square root of 3, except for that's not the final answer because we've got a radical in the denominator. So the last step here is then to rationalize. I'm going to multiply by what we call the conjugate, which is 1 plus the square root of 3 over 1 plus the square root of 3. And we get 1 plus 2 root 3 plus 3 on the top over 1 minus 3 on the bottom. Final answer then is going to be 4 plus 2 root 3 over negative 2, which simplifies to negative 2 minus root 3. All right, lots of steps. Most of them involved were actually in the simplifying of this problem and not anything else. All right, so give C and D a try. C is in radians. If you'd like, turn it into degrees first. I'll have the worked out solutions when you're done. So pause, give it a try, take a look at the answers in a minute. Okay, C and D are up. They're both actually the same. Just make sure you expanded correctly. 45 and 30 are not the only angles that you could use to get 15 degrees. You could take 60 minus 45 as well, but you should be getting the same answers, making sure that they're fully simplified. Otherwise, the internet online assignment will mark them incorrect. All right, let's take a look at example 2 and different type of example. You guys are going to be asked to draw a diagram here first, and then we'll find what the cosine of A minus B is. So we're given information about A and B. Let's draw the diagrams first. So if cosine of A is equal to negative 4/5, where A is between pi and 3 pi over 2. So pi and 3 pi over 2, that puts us in the third quadrant. So I am going to say this is diagram A, and we're told that the cosine of A is negative 4/5. So that means that the x value here is negative 4. The y value here is 5. This is a Pythagorean triple, so 3, 4, 5. Y needs to be negative 3 because we're in the third quadrant. All right, so the second angle we're given is B. We're told that the sine of B is equal to 5 over 13, and B is between 0 and pi over 2. So B is in the first quadrant. This is diagram B, and the sine of B is 5 over 13. So opposite over hypotenuse. This is another Pythagorean triple, which is going to be 12 here. Okay, all of those are positive because B is in the first quadrant. Now, we're asked to find the cosine of A minus B. So the cosine of A minus B, that is cosine A, cosine B, plus sine A, sine B. Cosine, cosine, sine, sine. We change the sign because cosine and change both start with a C. Okay, so let's fill this in. Take a look at your diagrams. Go to the diagram for angle A. The cosine of A is negative 4 over 5. The cosine of B, so switch diagrams, go over to B. The cosine of B is 12 over 13. Okay, going back to diagram A, the sine of A is negative 3 over 5. And then back to diagram B, the sine of B is 5 over 13. All right, so we've got all of our values, so now we just multiply and simplify. So negative 48 over 65, and then this becomes minus 15 over 65. Our final answer then is negative 63 over 65. Don't think we can simplify that, so we leave that as our final answer there. All right, so give example B on the next page a try. Draw those diagrams, simplify, and then come back and check your answer. All right, final answer for B, negative 87 over 425. Check your diagrams, make sure everything is in the right quadrant, and you've got the signs correct for sine and cosine there. All right, let's go on to example 3. We want to simplify the following expressions here. I'm going to do A and B with you guys, and then you'll try C and D on your own. Example A, the cosine of x plus pi. We want to simplify this, so we'll take a look at what we've been practicing. We've got A plus B here. So the cosine of A plus B, we will expand that. That is cosine A, cosine B, minus sine A, sine B. So remember, cosine and change both start with A, C, so we change the sign there. Now, A is just x, so we just replace A with x, and then B is pi. So what happens is we have one thing we can evaluate, the cosine of pi and the sine of pi. Pi is a unit circle angle. So the cosine of pi is negative 1, and the sine of pi, which is kind of really nice, is 0. So this whole term goes to 0, and we're just left with the negative cosine of x as our final answer. That's how we simplify that. It's kind of what we're looking for here. All right, let's try one more. We've got the sine of x minus pi. That's the same thing as saying some angle A minus some angle B. That expands to sine A cosine B minus cosine A sine B. Sine and same start with an S. We keep the sign the same. All right, try saying that 5 times fast. So this becomes the sine of x times the cosine of pi minus the cosine of x times the sine of pi. And again, what we see is we can evaluate cosine and sine of pi. So sine of x, the cosine of pi is negative 1. Cosine of x we can't do anything with, but the sine of pi again is 0. So again, our second term goes to 0, which is really nice, and we're just left with negative sine of x as our final answer there. Give C and D a try. Try and expand those and simplify. See what you get. Final answers for C and D, we get negative tan x and the cosine of x if we're expanding those using the sum and difference formulas. Email me if you've got questions on those. We're going to move on to the last 2 examples here. So example 4, I am going to do with you guys, I'll do the first one with you guys and give you guys some time to do the second one, and then we'll finish up with example 5. So we've got this. We want to solve. So we are told the sine of x plus pi over 3 plus the sine of x minus pi over 3 is equal to 1. And we want to find all the solutions between 0 and 2 pi. So all the solutions that make this equation true between 0 and 2 pi or 0 and 360 degrees. We'll represent our final answers in radians because that's kind of the domain that we're given here. But let's take a look. So we're going to use the expansion for sine of a plus b here. And I've got it as a plus b and then a minus b. So this is going to become the sine of x times the cosine of pi over 3. I'm going to expand this first part. Plus the cosine of x times the sine of pi over 3. And then I'm going to switch colors, because now I'm going to expand the second part. So to that, we are adding the expansion for the sine of a minus b. So the sine of x times the cosine of pi over 3 minus the cosine of x times the sine of pi over 3. And let's see what happens. Well, immediately, we've got a positive and a negative cosine x sine pi over 3. So those cancel out. And then we're left with 2 sine x's cosines of pi over 3. So, what do we have left? Well, the cosine of pi over 3 we can evaluate. That's a unit circle angle. This is still equal to 1, by the way. We're solving an equation here. So let's evaluate the cosine of pi over 3. Find pi over 3 on your unit circle, and the cosine of pi over 3 is 1/2. So we end up with the sine of x is equal to 1. The question is now on the unit circle, so between 0 and 2 pi, where is sine equal to 1? Where are the y values of those ordered pairs on the unit circle equal to 1? Now, mathematically, the way that we're going to do that to get x by itself, which is ultimately what we're solving for, to get rid of sine, we don't divide by sine because x is on the inside of that. We take the inverse sine. in order to get that. But this is asking what angles on the unit circle have a sine of 1. And there's only one. That is at pi over 2. So that is our final answer for part A. All right, see if you guys can do B. I'll have the fully worked out solution in a minute. Pause this video, come back when you're done. B is a little bit trickier. If you guys haven't noticed already, we first expand using the tangent of A minus B. And then what happens is we have this equal to 0. We're solving for 1. This is equal to 0. So in this step here, what I did is I cross multiplied, or I multiplied everything by 1 plus tan x, both sides. And that just goes to 0. So we're looking essentially for where the numerator, or tangent x minus 1, is equal to 0. And then when I add 1 to both sides, we get the tangent of x is equal to 1. So we're looking for what angle on the unit circle yields a tangent value of 1. So if we're looking around the unit circle, remember tangent is always y over x. So we're looking for where the y and x values are equal to one another. There's actually 2 angles on the unit circle where x and y are equal, pi over 4 and 5 pi over 4. So in the first and the third quadrant, we have tangent values that are 1. So we have to list both of those angles because we're looking for all of the angles between 0 and 2 pi. One of the trickier problems there. All right, last example we're going to work through for 9-8. That is example 5. We've got the situation here. So the index of refraction of a transparent material is the ratio of the speed of light in a vacuum to the speed of light in the material. We've got a triangular prism like the one that's shown. It can be used to measure the index of refraction using this formula that looks really, really ugly. For alpha is equal to 60 degrees, we want to show that the formula can be rewritten as something a little bit more simplified. So let's plug in what we know, and then we'll go from there. We'll simplify. So if n is equal to the sine of theta over 2 plus alpha over 2, but we are using this formula when alpha is 60, I'm just going to plug in 60 everywhere we see alpha. And then we'll see what happens. So we end up with this. This is the sine of theta over 2 plus 30. And then the denominator is still going to be theta over 2. Okay, so let's expand the top using the sum and difference formula. This is a plus b. So this is the sine of theta over 2 cosine 30 plus cosine theta over 2 sine 30. And then this is still over our denominator, the sine of theta over 2. Okay, I'm running out of room. I've got to move it up here. We can simplify the cosine and the sine of 30. The cosine of 30 degrees, if you go to your unit circle, that is the square root of 3 over 2. And then we still have the sine of theta over 2. We don't know what to do with that. We don't know what theta is. And then the sine of 30 is 1/2. So this becomes plus 1/2 the cosine of theta over 2. And then this is still over that ugly denominator, which is the sine of theta over 2. Okay, next I'm going to break these things out into a separate denominator. All right, so this is root 3 over 2 times the sine of theta over 2 over the sine of theta over 2 plus 1/2 cosine theta over 2 over the sine of theta over 2, and then we'll see what happens. Well, the sine of theta over 2 cancel in the first term. That just leaves us with the square root of 3 over 2. And then cosine over sine, we can simplify that. That becomes the cotangent of theta over 2, and then that 1/2 means we have that over 2. And that's essentially what we were looking for at the very top. So we've got to that point. This was just another kind of trig identity situation where we were verifying something. We were verifying equality of these two things. Okay, that is it for 9-8. There's one more lecture that doesn't have a set of notes to go along with it, but you guys are going to finish the homework kind of differently than the other homework assignments.